Assalamualaikum warahmatullahi wabarakatuh. So hello everyone. It's been quite a long time since I actually created a video. So today I would like to continue on a video which actually I have developed. We have actually recorded regarding introduction to statistical quality control. So this is the second series of introduction to statistical quality control that I have introduced to you earlier using the Montgomery's chapter slides. And I believe I have discussed about Deming and the 14 points of Deming proposed by Deming in terms of quality management. And also the PDCA cycle, Plan, Do, Check, Act, which been is also called as the Schuhart cycle, Plan, Do, Check, Act. It's very common in many companies, especially in the Japanese organizations, PDCA, Plan, Do, Check, Act, PDCA. Plan a change or an experiment aimed at systems improvement or even small low-hanging fruits improvement plan, and carry out the change or investigate, find out the problems, the causes of the problem, and try to find countermeasures to improve that, and then you move on to finding out whether the change or the countermeasure that you are going to take, the new system, the new procedure is effective or not. That means you study and analyze the results obtained and what was learned. And finally, you standardize, you adopt the change or you abandon the improvement idea. If adopted, make sure it leads to permanent improvement. So in Japanese, it is the stage of Yokoten or standardization, and standardization across the processes of the company. Okay. Okay, right. So this is Deming's idea on what is the obstacle to success, the belief that automation, computers, and new machinery will solve problems. Not every problem can be solved through automation, through introducing what they call database or software, you know. So we need to find for to copy existing solution. There are many solutions that the problems have already been solved, so you need to just copy them. So we need to find out whether if we are exhibiting the same problems, because most of management issues of lack of coordination, you know, poor execution. These are common things that exist in many organizations and just can be copied. If the procedure is shortened, what will be the effect? So that there are principles that will solve the problem, which are actually universal. So this is Deming's, opinion. Reliance on inspection to produce quality is also not effective. Okay, reliance on QC department, letting the QC department to take care of all quality problems won't solve problems, and then blaming the workforce for problems is also not going to solve problems. Also, Deming highlighted that false starts, such as broad teaching of statistical methods without a plan as how to use them, is going to be ineffective. It's bound for failures. You need to have targeted group in which you develop the statistical knowledge and skills. Um, the fallacy of zero defect, companies fail even though they produce products and services without defects. No, this is not necessary that you achieve success by introducing zero defects. And meeting the specification is not the complete story in any business. It's not just about meeting the specification, it's more than that. It is actually trying to solve the problem that actually exists in Gemba, in the workplace. In adequate testing of prototypes, prototype may be one-off article with artificially good dimensions. We need to know the actual mass production variability. Knowledge of variability can only be understood through mass production, through understanding the voice of the process as the process matured, as you learn more about the process, particularly, new processes, new technology need to be understood continuously. So he said that testing a prototype tells very little actually. There is symptom of inadequate understanding of product design, development, and the overall activity of technology commercialization. It's not easy. We need to actually, it takes a long time to actually understand a lot of things. Okay, this is bizarre thinking, according to Deming. This is bizarre thinking. Anyone that comes to help us must understand all our about the business. So using consultants to solve organization problem is not all. There are things which the consultants actually do not know. At the end of the day, I've seen that consultants they come to companies and they ask employees the answers. They get the answers from the employees. So at the end of the day, if the problem is solved internally, it is much better. It can be done internally. You don't need to get outside people to solve your internal problem. You may want to, provide some ideas, new knowledge. For example, Taguchi methods of design of experiments that can be done through training, but the actual implementation must be by the employees themselves. Okay. So another guru of quality is Joseph Juran. I admire him in terms of his thinking, the way that he proposes projects as a basis for continuous improvement. Until today, there is a Juran Institute that actively promotes the Juran philosophy and quality improvement practices. In fact, he's one of those who actually went to Japan to teach the Japanese, including Deming, and teach Japanese on quality concept. So he suggested this trilogy, the planning, control, improvement trilogy. Okay, quality planning, quality control, quality improvement. I don't know which way around, but this is the three areas. So these three processes are interrelated. You need to do quality planning and you need to execute it through quality control according to Juran, and you need to do quality improvement. And he emphasized project improvement. And also, there is a difference between control versus breakthrough. The control is something that you continuously, have to go do inspection, and then you do control charts. But breakthrough, you need to have technology to actually solve the problem, eliminate the problem. Another gurus in quality management or quality control, we have Kaoru Ishikawa, the Japanese son of the founder of JUICE, which is the Japan Union for Scientists and Engineers. And he was fundamental he was the founder, or he's the inventor for the 7 tools of QC. So Kaoru Ishikawa managed to actually simplify a lot of the two statistical inclination. So he proposed the scatter diagram, the simplified control charts, as well as the Ishikawa diagram or cause and effect diagram. And another one is also an engineer, Arman Fagenbaum, who wrote the book Total Quality Control. Well, I have the book for TQC, it's a very old book. And he promoted a systems approach towards quality, the organizational involvement in quality. A three-step approach which emphasize quality leadership, quality technology, and organizational commitment. Of course, there are other gurus which are lesser what they call known. I would like to mention Professor Kanji, or the late Gopal Kanji, Professor Zairi in the UK, and many others today. Has actually emerged from this quality management. So TQM started in the early 1980s and was actually the consultant. TQM didn't derive from the academic world. It was actually derived from the consultant world. And the emphasis to actually adopt TQM must be through training, widespread training and quality awareness. But problem is training often turn over to HR function. It should be from the engineering or from the production or from the industrial engineering function that should actually promote total quality management aspects. And TQM not enough to emphasize, not enough emphasis on quality control improvement tools that result into failed attempt in TQM. And today, I mean, there are quality is given, but still we have a lot of quality issues, even non-provision of services, water cuts, what do you call mobile phone reception, poor reception. These are all examples of poor quality services that we customers have to bear and have to be, patient about, especially in developing countries like Malaysia. So not enough emphasis on quality control, improvement tool, poor follow through, no project by project implementation strategy, no companies fail to actually have a continuous improvement system in place. And that's why TQM was largely unsuccessful, but not because of TQM. TQM is a very powerful tool and not tool, philosophy. It was unsuccessful because of the poor execution by the people or the managers or the engineers who actually fail to understand the true philosophy of TQM. Because TQM is seen to be just another program. It will fail. When any new initiative is seen just another program, it will fail. Like value engineering or default, zero defects. So anything, that's why Deming said that it must not be put as a slogan for organization. It must be built in and developed to be a culture in the organization. So if it is just another program, it is a recipe for ineffectiveness and maybe disaster, right? So that's the reason why TKM has been successful in some organizations, but not in all organizations. Another important aspect in total quality or in quality management is the quality system and standards. It started in 1987, the first ISO 9000 standard, okay? But I need to just highlight, okay, it actually comes from BS 5750, the British standard, the precursor to quality assurance. It was actually, but well before that, is the defense standard. Anyway, this actually, a documented system for implementing quality in organization in a specification form. It outlines the requirements right from the control of processes, production processes, the marketing processes, the purchasing processes or activities that you actually conduct in order to achieve, your quality, product quality, or even your processes. It is broadly applicable to any organization. It is used to demonstrate a supplier's ability to control its processes. Okay, and today I think the latest one is 2015. Okay, this is a bit old. Okay, if I'm not mistaken, 2015 quality management system fundamentals and vocabulary. There is guidelines for performance improvement. I'm glad to see that the latest, version of 2015 has moved towards a total quality concept, not previously where it is too production focus. It was only a quality assurance focus. So now it has moved to TQM. So those who are familiar with this will be able to know that there are clauses. They have revised it and put in the risk elements inside the ISO 9000 risk management. The company must select a registrar, prepare for certification audit. So you can talk about this preparation for the documentation of the system and doing this certification audit and also surveillance audit annually or biannually in order to ensure that the certificate that you gain is maintained and not pulled out or not being retracted by the certification body. Okay, and after that, because of the increase in management system development for companies to show proof that they have a quality management system, then there was later on it resulted into 14,000, which is actually the environmental management system standard to be developed for automotive related. It was formerly QS 9000, but now it is TS 159. Okay, I forgot. Okay, but it is the International Task Force on Automotive, ITAF. So they actually have additional requirement for automotive related business companies producing parts or components or even manufacturers of auto vehicles. But anyway, systems quality, some companies, they go through the systems approach, quality system way of trying to change the organization to adopt a quality system. Later on, also in 1987, it was developed in US. Countries like US, they see the need to actually develop a quality award model for organizations to motivate organizations to implement quality, management. And because of this award, it was actually given to those excellent organizations. It's an excellent organization award kind of system. So the Malcolm Borish National Quality Award given to organization in 5 categories: manufacturing, service. But I need to point out that the first quality award is not Malcolm Borish National Quality Award. It is actually the Deming Prize. Okay, the Deming Prize, which was started, if I'm not mistaken, in 1960 in Japan. It's the same kind of system, award excellent organization. Okay, of course, if you don't want to enter the award, if the companies also want to use this as criteria for self-assessment, so it provides performance excellence criteria for self-assessment. in order for the organization to assess whether how much they have actually achieved in terms of, for example, process management. How good are their process management? How good are their supplier management, for example? Okay, so it provides performance excellence criteria and point values, and so it is in a way trying to assess in various aspects of total quality or quality organization excellence. In Europe, it's called business excellence. Okay, in Europe, business excellence framework or models. It's the same kind of criteria. For example, leadership, total quality management, leadership, strategic thinking, and all these have criteria and descriptions of what the organization should have or should do, what are the activities, what are the mechanisms that should be in place, what are the systems that should be in place, what are the activities that should be in place, or particularly including policies, in terms of human resource, how do they actually select human resources that have an impact on their processes, their jobs. For example, how do they appoint or purchasing managers, for example. Purchasing have certain policies. How do they ensure that the purchasing process selects the best suppliers? How do they ensure that the suppliers are being developed? How do they ensure that the suppliers which are not performing are being feedback on their poor performance? So you need to have all these criteria and what are the impact on the business results, and as well as the information and analysis, the data that is required to do continuous improvement in the processes. How are they collected? How are they analyzed? Problems that identified being addressed. Okay, and of course you have to all this must be based on the organization's business that they are in, what kind of environment, and then the relationship between partners, suppliers, stakeholders, and challengers. So it is organizational excellence criteria. It's called Montgomery in US. And this is the process in Montgomery National Quality Award criteria, right from receiving application for award right until the judges recommending winners. In Malaysia, there is you can view my video on business excellence model for Malaysia, which I have actually developed, which I've actually recorded. Okay, the next important, I think this is the last thing that actually has developed in TQM, Six Sigma. Because the development of quality management has evolved from the first industrial revolution in terms of inspection, move on to quality control, quality assurance, then move into total quality management. And there are studies that actually try to say that because TQM is not tangible, it doesn't show results, it's just a philosophy, and that is the reason why Six Sigma became popular. Okay, what is Six Sigma? Six Sigma is a philosophy, it is a system in which it is trying to improve businesses using statistics, understanding variation, and other tools that will actually identify problems and put out a business case and trying to reduce the variation. Variation is calculated using sigma. Okay, sigma. That's why it's called Six Sigma. Six Sigma is a state in which it is excellent. Okay, where variation is very, very low, very minimum. So if you see the development of the other tools like SQC, which are incorporated into Six Sigma, OR tools, and other exploratory other tools, okay, TQM movement in 1980s, and there's a stage of re-engineering, really business process re-engineering, BPR, which actually tried to improve processes as well. Then only in 1987, but it was popular in 1990s in Motorola as well as GE, General Electric. Okay, so Six Sigma adopted most of the statistical tools of quality control, but the good thing is that it has structured the improvement program for organization to actually see the business impact. So the focus of Six Sigma is on process improvement, emphasizing significant business impact. They will calculate, and they will see whether there are any cost savings, because it is going to be translated into cost savings. Companies must think about cost savings. Okay, cost is more important than quality. That's what my friend Shin Taguchi always said. Cost is more important than quality. Okay, so you think about it. So process is an organized sequence of activities, produce output that adds value or perform in interconnected processes, especially in manufacturing. And because I came from manufacturing, it's easy to see because we have very tangible conversion of raw materials, converting into different forms, doing welding, doing cutting, doing casting. So it's very clear. So we can actually see and identify the defects. When it is rejected, we can see, you can count it, you can visualize it, okay? But of course, in service organization, it's harder to see, but it can be done also. Six Sigma can be done in hospitals. Six Sigma can be done in banking. No issue about it. As long as there are variation, as there are people. So any process can be improved. So some people don't believe in, it's very difficult to improve this service process. No, service processes can be improved. Anything that has human, that has variation can be quantified. Okay, you can quantify time. Time is measurable. Steps taken, you can calculate, you can count. Right? So organized approach is necessary. The process focus is essential to Six Sigma. Okay, so this is the common description statistics that is used in Six Sigma, which is this is a normal distribution. Okay, a normal distribution, a bell-shaped Gaussian distribution. If the process with lower spec, upper spec having variation of plus minus 3 sigma, for example, if the average is 10 and the 10 millimeter or whatever, and if sigma is 2, then plus 3 standard deviation is 16, minus 3 standard deviation is 16, minus 6 is 10. Okay, so this is your process performance. Process performance is, the products produced are from 10 to 16. This is 99.73% acceptable or good. Assuming that the upper specification, for example, it is the upper specification limit is come from drawing, come from standards, come from specification. So assume that it is 22 here, okay, 22 millimeter. And here it is, let's say it is, well, it cannot go to, okay, let's say it's 2, okay, 2 millimeter. So 2 plus 10, well, it's 5 sigma away, okay, 5 sigma away. So the spec limit is way, if it is the same as the process limits, so we are saying that 3 sigma is 99.73%. But if the spec limit is way beyond, so you're talking about percentage inside the specification to be 99.9999998, which is translated into 0.002 defect per million, okay, DPMO, defect per million opportunity, meaning zero defect, meaning zero defects, especially because, you know, tangible things, there is a cut off. You cannot have, you know, the dimension which is actually beyond this sigma, okay. So this is normal distribution centered at target. If it is, there is a deviation, 1.5 sigma deviation away from the mean, then if it is away from the mean 1.5 sigma, for example, the target should be 10, but, you know, because of some reasons, it is at 11.5, for example, that will push your process limit to plus 6 and 17.5, you're still having a 3.4 defect per million, okay? Still zero, basically. So even there is a shift, there's a shift, because processes are not always at the center. The processes are not always at the center. So you have a process drift, drifting away from the specification limits or the control limits. So this is the Motorola Six Sigma concept. Very, very important to understand it. I probably will develop another specific video on this, but this is the Six Sigma. So if processes, imagine if your process is at 1 sigma, that means your, for example, your variation is huge. Your sigma is 4, for example. Okay, so 10. So 3 sigma is plus 12, which is 22. If the specification is at 16, so all these are actually rejects. Okay, all these are rejects. That's why we have, if 2 sigma, 45,500 defects per million opportunity. So imagine you want to get services from a 6 sigma process or from 1 sigma process. Typical example, you know, airports have flight taking off and landing. So if you, in the long run, say 10-year record, how many million landing or how many thousand landings. So do you want an airport or an airline which actually has a record of, you know, like 3 sigma. 3 sigma is 3 defect per 1,000. So 3 defect per 1,000 means every 1,000 flights, there will be 3 landings or 3 takeoff, which are having some errors. I don't want. I want a 6 sigma airline providing only 0.002 fault, defect, or error per million operations. Okay, so think about it. So why quality improvement is important? Okay, just a simple example, a visit to the fast food, hamburger. Okay, this product has 10 components, it's 99% good, okay. The probability of single meal good is, okay, this is reliability, 0.99 to the power of 10, which is 0.9044. So family of 4 once a month, probability of all meals good is, because we have family of 4 to the power of 0.690. And probability of all visits during the year good, 12 to the power of 12, 12 months, so it's 0.0080, okay. So this is the probability issue that actually face. So do you Do you think 99% is good enough? Okay. Do you think 2 sigma is good enough for that matter? So you can calculate and you can measure sigma in all processes. All processes can measure sigma. Okay, all processes can measure the errors produced per thousand or per million opportunity. So the initial focus for Six Sigma was in manufacturing, but it was later adopted in banking, finance, public sector services, and it can be employed, can be used. If you apply Six Sigma right from the beginning, it is called design for Six Sigma. That means the process of trying to determine or create new improvements, should start from Six Sigma, where you need to use a lot of new design. What do you call it? It's called design for Six Sigma, DFSS. So in terms of new process design, new product design, you need to actually, we can use design for Six Sigma. Okay, some commercial applications of Six Sigma, reducing average and variation of days outstanding on accounts receivable, managing cost of consultants, keep tracing, credit scoring, closing the books, time to close the books, time to process claims, audit accuracy, forecasting, inventory management, and so on. So all processes is open. I mean, you can do improvements. So Six Sigma is a discipline and analytical approach to process and product improvement. There are specialized roles for people. There are champions, master black belts, green belts, and it is top-down driven. That means the champions come from each business units in the organization. Last week, I heard a talk from one of the companies in Malaysia that is actively using Six Sigma, and you can see that the organization will actually gain a lot in terms of saving and in terms of understanding the processes. Any processes can be improved. However, I would like to point out that companies must try to do the try to apply the they're trying to solve the complex problems more, doing research through design of experiment, Taguchi methods, DFSS. I mean, low-hanging fruits are very easy to be improved. Even you don't need Six Sigma to improve low-hanging fruits. I mean, low-hanging fruit means simple problems, commonsensical problems. Okay. So black belts and master black belt has a responsibility. And Six Sigma, I mean, some of you probably have heard of it, DMAIC, D-M-A-I-C, define, measure, analyze, improve, and control. That is the structure, or is that is the system that actually developed. So every stage, you need to define the problem, you need to measure the impact or how bad is the problem, you need to come up with countermeasures, and you need to analyze the problem using, I don't know, tools like 7 tools, or you need to analyze using design or experiment. You need to ask 5 why, improve, and then control. Control probably have, Yoko 10 control charts and other things. So what makes it work? Because of this thing. It is a difficult, you need committed leadership. Leadership or the top management must understand what Six Sigma is all about. They must understand variation. So all processes have variation coming from man, machine, material, method, environment, and materials coming from different suppliers have variation, and use of top talent. Okay, project by project improvement strategy borrowed from Juran. So this is the structure of the Six Sigma organization. Okay, leadership team, the master black belts, the green belts. It is a very formal and organized structure. And imagine the amount of improvement that can be done. Let's look at logistics alone. We can do a lot of Six Sigma projects in logistics. Okay, So, or even in engineering. So this is the methodology. Okay? Taking variable reduction upstream for manufacturing into the product design is designed for Six Sigma. Okay. So customer critical to quality characteristics must be identified. What are the system parameter, what are the subsystem parameter, and so on. This actually combines quality engineering by Taguchi. So we talk about parameter design systems and trying to optimize the design. Okay. So there's a lot of other things that can, DFS matches customer needs with capability. We need to see the organization technological level against, you know, the ability to manufacture it. Okay, if the amount of variation, we're talking about robust process, robust product to customer. Customer uses a product based on, you know, their own culture, way of life. So if they, you know, for example, a car, they closing a car door, you know, you cannot limit this amount of force exerted by the customer. If a customer, you know, like to bang on the door, you have to design so that the door doesn't break, you know, easily. So you must, I mean, that's, so you must consider mean and variability in the design phase. Okay, you must optimize design or make design robust to variability, from manufacturing variability, environmental variability, and usage variability. You know, so that can be incorporated in DFSS. And other things that must be considered, there is a huge product concept where identify are customers real. Will product customers buy this product? This is a business question. Has a plan for transfer to manufacturing been developed and verified? So there must be, you know, transference of the prototype production, pre-prototype production, process confirmation, product quality confirmation. So this must be conducted if you really want to ensure that cost savings, you want to ensure that customers are satisfied thoroughly. If we don't do this, then that is why all the issues of you know, service breakdowns, because no detailed plans and programs are being done. Okay, so DMIAC solve problem by using Six Sigma tools. So they use the DMIAC approach. It's problem-solving methodology similar to Schuhart cycle. So you need to use this method to solve problems. So in Six Sigma, it is you religiously follow DMIAC. Define problems in process, measure performance, analyze causes of problems, improve processes and remove variations, and control processes. And now, because of you know, the lean concept coming into manufacturing as well, the Toyota production system. So now you expect that Lean Six Sigma. So focus on elimination of waste. So not only focusing on quality per se, but we are looking at whether when you produce the product, or you know, when you try to make the quality, will it result into waste, long cycle times, you know, mudah, okay, waste, duplicate throughput, rework, non-value added work activities. So you make use many of the tools of operations research, industrial engineering to actually make the reduce waste in all our processes. Okay, process efficiency is value minus value add time divided by process cycle time. For example, this process cycle time work in process over average completion rate. Average completion rate is a measure of capacity. If the average completion rate for submitted applications 100 completions per day, there are 1,000 applications waiting processing. So process cycle time is 15 days. So do you think 15 days is good enough? Do you think that 15 days is, we reduce the cycle time? So we can use lean lean management or lean manufacturing for that matter. So lean focuses on waste elimination. He has actually encroached into the total quality management field. I do not know whether lean is at the above or TCAM is at the above, but anyway, today lean should be the combination of lean and Six Sigma. Lean helps identify anything not absolutely required to deliver a quality product on time. So benefits of lean have reduced inventory, lead time, and costs. Cost is more important than quality. Cost is more important than quality. So lean methods includes productivity, quality, on-time delivery, capacity, and sales. Okay, so this is the Six Sigma, Deming, Lean, and DFS, how they fit together. So today, currently, this is where we are now in terms of TQM, total quality management, or even organizational excellence methodology, which is the combination of DFS, Lean, as well as Six Sigma, Deming. Okay, this is the excellence framework in terms of technical, okay, in terms of tools. But of course, you can use the Montgomery or even the Quality Award for management, for management excellence. And combined with supply chain quality management, today supply chain represents the significant component of total value. Again, because in supply chain, we can make the supply chain lean by having a lot of the waste being eliminated. Because supply chain is the chain, the value chain of any industry or any product. So it must be optimize. They must ensure that all businesses, the distribution and delivery to distribution centers and customers are efficient, effective, meets the customers' needs, and there is there are not much waste. Waste will translate into cost. Okay, so cost is more important than quality, right? So key supply chain processes encompass service management, demand management, all these things. So not only for manufacturing, you talk about service organizations, or even delivery services, or even food industry, or even the restaurants. Today, because of the pandemic, logistics of the online businesses is flourishing. You see a lot of delivery services being created to support the online purchasing, online commerce, from Shopee, from Lazada, from Amazon or whatever. Okay, so this is the supply chain. Supply chain must be enhanced. Okay, so I remember during the pandemic where the supply chain for agriculture products, okay, are being disrupted. Okay, there's a lot of wastage. The agricultural produce being destroyed or just gone to waste because of spoils. Okay, so key supply chain management activity includes supplier qualification, certification, supply development, supply audit. So this encompasses into total quality management in terms of having excellent suppliers to supply to their production lines. Okay, in returns management, how do they actually engage on how do they actually manage the return parts, the warranty parts, and so on, okay, or recall campaigns. And it falls under the quality cost. I have a video on quality cost. You can look at the video on quality cost for more detail on prevention, internal, external, and so on. And there are a lot of wastage in offices as well. They call it the hidden factory or the hidden office. A lot. The distribution of revenue by percentage in typical manufacturing organization. Okay, right. And another aspect of quality, when you talk about total quality, is the legal aspects of quality. There are product liability exposure for any kind of products. Okay, there's a concept of strict liability, the responsibility of both manufacturer and seller and distributor to actually abide by their promise to the customers. If they're not able to fulfill their customers' requirements, their product fail in the market, they need to actually, replace or repair and so on. And advertising must be supported by valid data. So advertising must be truly reflective, and the final product must be truly reflective of the promises in the advertisements. Okay, so that is part of our social responsibility. So implementing quality improvement is a strategic management process and should cover all the dimensions of quality, and suppliers and supply chain management must be involved and must focus on all three components. This is according to quality planning, quality assurance, and quality improvement and control activities. So you must first plan and have assurance activities, and when you produce the service or you deliver the service or the product, you must have quality control and continuous improvement. So improvement is key to excellence. Okay, key to excellence is improvement. Okay, I think that is about all for this part 2 of statistical quality control. I hope you learn some things. If you have any questions, please share in the comments. Okay, thank you very much. I'll see you in my next video. Assalamualaikum warahmatullahi wabarakatuh.